Yeah, lovely to see you again.
Lovely to see you.
And so, how have you been? How's it going?
How's you been? I was reminiscing, actually, I've got to say, I was reminiscing with Kevlin yesterday. We met at this conference, or at the forerunner to this conference, YAO, in 2004, so practically 20 years ago. I was a noob. I was a rather terrified noob. I'd just come off a stage talking with Martin Fowler, which is an interesting experience in itself. I was on a panel, and the way they'd done that particular YAO was that each track had its own panel at the end of the day. And we were on a panel about process and how software process works. And there was the compere, the MC for the moderator for the panel was this chap, Kevlin Henney. And the first thing he said, as we all sat down on the panel, is he said, right, has everybody got a drink? Like, where's that? He said, well, it's a panel. Everybody needs a drink. We got everybody beer. I was like, this is going to be a fun panel. And yeah, we've sort of been pals since, I think.
Yeah. I mean, it sets the benchmark. You know, that's how you're going to do it. And that was a fun panel because I mean, so let's situate that. 2004. The word agile is coming into currency. You have basically been formulated. BDD is this kind of thing that's happening, and you know,
still very nascent.
Yeah, the ideas are kind of coming together. Was there a promise of a book back then? I just want to figure out how long.
I mean,
had you talked about a book, or was that a couple of years later?
Well, no. So I have an excuse. By the way, I'm undiagnosed ADHD. I'm 12 years into writing a book. I have 2 other books that I'm failing to start writing. I deliberately never wrote a BDD book. That was a choice.
Well done.
And the choice not to write a BDD book was kind of made for me. A wonderful chap called GOTO Copenhagen, who was a very early adopter of BDD. He wrote a book, and the book's called Bridging the Communication Gap. And he sent me a copy of this book. He said, I've just ripped off your stuff and written in a book. And I read this book, and I was like, that's the BDD book. I don't need to write a book now. And people said, are you going to write a book? I'm going, go read GOTO's book. And over the years, like various other people have written actually really good treatments of BDD, and I'm like, I don't really have anything to add to that. So, you know, and one of the things I love about, and this was, actually I'm going to name drop again, Kent Beck. I met Kent after a bunch of years. I didn't meet him sort of early in my career, in my agile career. But we were talking about certification. We both have fairly similar views on certification. And he said, I said, so why didn't you kind of trademark, like protect the IP of XP? So I didn't want to do that. I didn't want to monetize it in that way. I wanted people to go, put it out in the world and share it. And that massively influenced my decisions and my choice around BDD and its IP. And it paid off. Like you get like the Liz Keogh, Chris Matz, I'm going to forget what names are, John Ferguson Smart, just some brilliant people who've taken these ideas and grown them. Aslak Helisoy, right? All the Cucumber Gang, Matt Wynn. Just some wonderful human beings who've taken these ideas and taken them off in directions I'd never have thought of. I'm like, yeah, go do that. That's cool. So yeah.
There's that. You see, that's true leadership. If anybody's looking for a leadership talk, this is it. Okay, well, it's just like
Well, so one piece of advice I got early on, and it was nothing to do with tech. It was just I think it might have been a ThoughtWorks. Someone said it. They said, if you want an idea to go a long way, don't try and go with it. And I went, oh.
Yeah, I'm doing the same thing now.
Don't try and go. If it's a good idea, put it out there. Don't try and go with it. Don't be associated with it. Just let it be its thing. Right? And yeah. So you put it out into the world and see what happens.
I've done things that are similar, not quite as big as that, but I do now recognise a pattern, and now retrospectively I can claim all the clever stuff you just said, which is great. But yeah, so a few things have changed since 2004, and a few things have remained the same.
You're still just as good looking, Kevlin.
Yeah, when you start from that, it's like the first joke I told. When you start from that level, it can only get better. So there is the whole. There's the whole thing. So I'm kind of interested in the. What are we going to be talking about in 20 years' time?
I was going to say, there's a teleology thing here, isn't there? There's like,
Yeah.
we've gone, right, 20 years to here, and then where does it go?
We're going to survive year 2038, the year 2038 problem.
Yep.
Yep.
By a ton of work, and then immediately afterwards, people are going, see, it was completely made up.
Yes.
No, that was never a problem. And a whole load of exhausted programmers are going to go, I hate you. I'm going for a lie down now. And a load of contractors will have made an absolute killing in the banks.
Yeah, I think you're right. I think so. Okay,
So
so
that
that happened. Yeah.
And we'll get to 2040, yes.
Yeah. So what are we going to be complaining about?
Language is not moving on.
Yeah. Okay.
I'm going to challenge something that you said in your talk. You said there's not many things of Kevin I would dare to challenge. My experience, I think, of modern or new emerging languages might be different from yours. You were saying that each language or each generation of languages is going to absorb all of the things from the previous languages and introduce some others. My experience is different from that. My experience is that languages whoever's designing the language tends to take a position.
Yes.
And the language then is an expression of that position, of those affordances. Yep. So if you look at Rust doesn't have everything in it. No. It has a very, very opinionated borrow checker that makes me feel stupid. And it has a very, very smart type system that makes me feel stupid. Right? But that's the choice of those language designers. Go is Nat Price describes Go as a language that's so ugly, the only thing you can do with it is work. It's brilliant. It's brilliant in its ugliness, right? Yeah. It just does programming, and it's looked at all of the smart language, emergent ideas of the last 40 years and gone, nah, I don't want any of that. I want 4. We're going to have the whole of looping, iteration, recursion, all that's going to be 4 loops. But what about if no? Okay, well, you're clearly informed by Python. What about list comprehensions? No, nothing that stops you typing the word for. and I love Advent of Code. I mentioned Advent of Code in my talk. I use Advent of Code to learn new languages, learn new technologies. And I did Rust in Advent of Code for I normally get about 7 or 8 days in. I've got kids, so I kind of got to squeeze it in the edges. And I was learning Rust, and it was great fun. And I started doing Kotlin. Kotlin's my happy place language. I love Kotlin. It's such an easy... Kotlin thinks how I think. I can write code, and it sort of just works. So I'm stomping my way through Advent of Code in Kotlin. I got to about day 10. I was like, I'm going to do the last few days again in Go, because my hypothesis is that Go code is going to be like a lot more verbose than Kotlin code for the equivalent thing. And it might have been actually something you said about the affordances of languages and how much work you have to do to get the same output. I was like, And so I started doing the few days of Advent of Code in Go. And the strangest thing happened. It's about the same amount of code. It's just different code. And I was like, did not see that coming. So it turns out that they are relatively equivalent languages. Just I'm so spoilt with things like functional affordances and maps and lists and reduces and all that. And I don't have those in Go. And Go's like, you don't need it. Honestly, you'll be fine.
Well, I just to pick up on a couple of things. One of them, certainly when I use the term all, I do not genuinely mean all. I started with the John Backus quote in my talk, and it's just like, because he sort of said, new languages, they do, yeah. So I wasn't going to moderate the generalization. No, they don't take everything, otherwise we really would grind to a halt. So what they do is
Well, you get Scala.
Hybrid. There we go. Bag
of language features fighting in a
But that's
sack.
the thing, is that each language does do that. And when you look at, so each language does start, and you're quite right, version 1 is the opinionated one the creator did. But that goes back to the other point that I made, is that, and then there's version, and then the one after that, and then the one after that. If you look at any programming language that's been around a long time, and that's the kind of the joke I was making about, when it's been around a while, it generally has different design teams and different design goals, and the world moves around it. And then what becomes fashionable and desired changes. And sometimes a language will hold out for a while, that eventually caves, and we're already seeing that Go is undergoing. So Python was actually surprising. Python 3 was really stable for a long time, but then it starts adding new control flow constructs. Control flow constructs are normally the last thing to get added to a language. They're really very, very,
That's the stable layer. You do not want to be messing with that.
Yeah, exactly. And it's now adding, and we're seeing that all of these things are changing. And I have, I've got, for some languages, I've got books from different eras, and it's so funny looking at what's recommended style. So that's the things I agree that normally it comes out. It's normally a small design group, small coherent, but then when it becomes popular, then it starts diverging. And in Java, there's a bunch of little languages trying to get out. They've been imprisoned, and they're all there. And so there's that aspect. But I think also the point that you made about when you look at Go, because somebody was talking to me about paradigms, and I was like, Go is kind of like perfect procedural. And funny thing is, if we were still doing the algol numbering, Go fits into that because it actually is sympathetic. Having read the reports of various, it's just actually really. Go is the most perfect 1970s language I've ever encountered. It is not a 21st century language. It is the heir to Algol 68. It has got all those things. If Algol 68 came along a bit later, it would have had channels. It had parallelism. It had all of these various bits and pieces. It had kind of like, you kind of look at it and go, yeah, simple. And there's a bunch of stuff you can do in Go where you're not surprised that it works because something else was supposed to work like that, and you just change the syntax. Oh, yeah, that works there as well.
Yeah, and the structural typing, like the fact that you can't have type hierarchies, but you can have types, and they can have methods. You're like, you can separate those two ideas and throw away the really complicated one.
There's a whole load of stuff there that it's kind of like, I'll be generous. I'll say early 80s on the outside, but it feels
well, but it's no coincidence, right? It was designed by one of the folks that designed Unix.
Yeah.
And he's looking at this, and he's looking at a bit of the sort of background of Go is he invented at Google, and it wasn't some people sitting around saying let's invent a language. They were solving a real problem. Google has one of the largest C++ code bases in the world. It's called Search. And it has one of the largest Java code bases in the world. It's called Ads. And these two code bases are pushing the limits of those languages, right? So for Java, it's just about how big of a thing you can build. For C++, it's linking. For anyone who was writing code in the 90s, right, it's a very, very painful and time-consuming process. And they're saying, okay, there's certain, again, it's a goodness of fit. There's certain situations, certain problems for which in Google, in our ecosystem, C++ is exactly the right language to do that part of search. But for huge amounts of the rest of it, for all the kind of the plumbing and the bits that kind of make it all work, it doesn't need to be that. Ditto Ads, right? And so what would a language look like that would have a really gentle on-ramp for Java programmers, a really gentle on-ramp for C++ programmers, a really gentle on-ramp for Python programmers that is deliberately small? We'll make it deliberately small. We're going to make it developer-friendly, fast toolchain. If it doesn't compile fast, it's no use. And that was why they pushed back on generics early on. It wasn't we don't want generics in the language. It's that will slow down. There is no implementation of generics that does not slow down a compiler or introduce several more passes, right? Yeah. So you're going to have to fight for this. If you can give me a reason to have this, you're going to have to fight for it.
But I think one of the funny things is when you kind of look at history, it's just like Java, Go's going to get generics. And I remember saying that in 2009, 2010.
Well, and that's what they said. They said, well, we're not going to say no. We're going to say, give us a constrained use case.
No, you don't have to. That was the thing. It's just inevitable. That's what happens to any statically typed language, or most statically typed languages that become popular. It's that they inevitably do it. It's just like, oh, you're reaching that phase. Yeah. It's like, oh, you're having kids now. Yeah. Okay. It's just one of those things. It's like, yeah, I'm not going to have kids. I'm going to stay young and rebellious. And here are my generics. It's just one of those things. It's a consequence of a static type system.
So there's a Bjorn Stroustrup paraphrase there, isn't there? Like there's two kinds of languages: the ones that no one uses and the ones that people add generics to.
Yes, exactly. Yeah. I love the fact that with Python, it's just like, we're going to add optional typing. Oh, yeah, we need to do generics as well. It's just like, there it is. So there's a certain inevitability. I should have said that in a kind of like Matrix, kind of Agent Smith kind of voice, but I won't try. So that's what we're going to complain about in 2044. When it comes to the way that we work.
Oh yeah, 2044. That's what we're talking about.
Yeah. So we've now caught up. Go's had generics for years. It's probably got a bunch of other stuff as well, and there's probably a shortened syntax form that's it'll have comprehensions. Okay, so that's Go 2044. Please, if you're watching this in 2044, rate this. How did we do? It's got a comprehension equivalent thing, and it's got generics are in, but they are now part of it. Okay.
Do you know what I'd like to think? Right, I want to stay with the technical stuff because I know a lot of the work I've been doing over the last 15 years is much more kind of organizations and teams and ways of working and stuff, but I still like to.
Okay, we're going to stick with the curly brackets.
Let's stick with the curly bracket languages. One of the things I would like to think we've gotten a lot better at in the next 20 years, like in STAR, we have to. And this goes back to Sophie's kind of talk yesterday, is that the hardware we've got now and the way we're reasoning about hardware is so far ahead of any capability we have to program to it. And we are so either deliberately or inadvertently wasteful of that resource that we have, that I would like to see a lot more deliberate move towards languages that are like necessarily sympathetic.
Yeah.
So your vector languages, I think like your APLs and your Ks and those sort of languages, I think are going to have a massive resurgence. There needs to be a more developer-friendly version of that.
There are a few, yes, but
I'm a fan of APL. I had APL keywords. I wrote reporting software in APL.
So for those of you who don't know, APL very
it's a
different
write-only language,
but very strong on the notation idea to the degree you needed a different keyboard. But there are more popular versions. But yeah.
But the point of a language like APL is it's called a vector language. So things like doing operations on vectors are like there's a single symbol, right? It's a single thing. Inverting a matrix is a single operation, or transposing a matrix is a single operation. And what that does is it gives to the compiler and the runtime an enormous amount of degrees of freedom, right? Because you're saying, I want to invert this matrix. It could, if all of those rows or columns of that matrix are in different registers, in different vector registers, it can basically go, there you go. Or if not, it can parallelize it out. It can do loads of really cool stuff that you as a programmer wouldn't think of.
Yeah.
Or even if you did, you'd probably get it in the wrong order, right? And so when you get languages that are at, and it's not necessarily a higher or lower level of abstraction, because that's a popular misconception as well. It's at an appropriate level of abstraction for the problem you're solving and for the affordances you've got, then you're winning. Right? And I'll keep coming back to Go. I sound like a Go fanboy. I write hardly any Go. I just think that Rob Pike is a very smart guy and designs and thinks very carefully about designing things. One of the things that Go has built in is baked-in concurrency. So it has Tony Hoare's CSP model, which is little processes, they call them Go routines, and all the processes are wired together with channels, and the channels are typed. So you send a value of a type down a channel, and as a Go routine, the only things you can do are receive a thing from a channel and send stuff down channels, right? That's your only connection with the outside world. If you define your program, and it's weird, right, for programmers, for who's here like Java, who are the Java folks, and Kotlins, and C Sharps, keep your hands up, C Sharp, Python, Ruby, what am I missing? Who's doing stuff and none of the above? Call out some languages. What languages are you using that aren't those? Right? JavaScript, PHP, of course, the two big ones, right?
All of the top 10. Yeah.
Right. In all of those languages, if I want to do some stuff, I go, do first thing, do second thing, do third thing, do fourth thing, and that's what my program looks like. Okay. In a CSP world, I would have little agents that do each of those four things. And I would define those agents, and I'd spin them up, and I'd just send a message from each one, and the work gets done. But the work is now being done in separate places, which is weird, right? But it turns out it's much easier to reason about than those 4 lines of code in terms of what's going on inside a computer. And when we start programming like that, each of those little things is its own little computer. And again, Alan Kay describing OO as little computers passing messages, and at the core of it's the messages. We've actually got, literally, Tony Hoare's describing this thing, little computers passing messages. And when you start getting, your Apple Silicon and your AMDs and your these chips that are they're called SoC, system on a chip. So you get a tiny bit of silicon, and on there is the memory and the CPU and the GPU and all of that stuff, all of that compute is in one spot. And if you have what they call locality, if the compute you're doing is happening on the memory that's also on that piece of wafer, then suddenly everything is like orders of magnitude faster than if you're having to pass things around, or if you're having to do each of those 4 lines of code, it involves necessarily a cache miss of the line before, right? So I'm going off to stuff all over the place. If I can start programming in a way that is sympathetic to the hardware that's been sitting there for best part of a decade waiting for us, right? Suddenly we're going to have, and this goes back to what Holly Cummins was talking about the economics of computing. I can make my computing better, faster, and cheaper by thinking about the context it's running in. Yeah. And I think we're going to, as a planet, right, as a species, we're going to have to get an awful lot better at that over the next 20 years. Yeah. And I feel like the pieces are already there. We're just not putting them together correctly.
I think you're right. I think the pieces have been there, and that notion that It's the that.
We're going to end up at Erlang, is what we're going to do.
We're going to, it's going to be, no, it won't be Erlang, because Erlang won't make it. It'll be somebody borrowing ideas from Erlang. That's how
Erlang will still be running, and it will still never have crashed.
Yeah, exactly. 2024.
The Copenhagen.
Is that Erlang process still running? Yes, it is.
Copenhagen telephone.
2024. Yes.
No, I have to say, the Copenhagen telephone exchange, like the original Erlang process, is still running.
Doesn't surprise me.
This is brilliant. So Erlang itself, Erlang is a language. It has this idea of called processes. They're like each process, like a couple hundred bytes of memory. A process has a mailbox. That's the whole programming paradigm. So it's called actor model. And the idea is that to get work done as a process, you send messages to other processes, and they have mailboxes. But the thing is, you can update a process. You can put a new version of a process in by just deploying it, and then the runtime, it's called OTP, the runtime starts channeling new messages into the new process's mailbox, drains down this one. As soon as this one's down, it kills it, and everything moves over to here. So you can update code live. Okay. Now, the Erlang operating system, the Erlang language runtime, is written in Erlang. So you can upgrade the major version of Erlang that your Erlang program is running in live underneath the program while it's still running. This has happened in the Copenhagen telephone exchange about 24 times, right? It's now running the latest version of Erlang. It has had Joe Armstrong, I met him a few times, and he said, after about 10 years, we stopped counting nines. Right, we stopped counting nines because it's had zero downtime in the whole time. We've done major updates of the actual language underneath the code. Never mind the code in that time. No downtime.
But again, that's just,
just insane.
So yeah,
well,
I mean,
because you make it so simple, it can't break.
Yeah,
right. And we don't do that.
That's the thing. That's the thing. So my keynote. The point is that it's like, yeah, how long is it going to take for that idea to take hold? Because the actor model was originated in was 50 years ago, along with at the same time.
You'll know the paper, right?
It's just like I did my master's thesis was on actor models, and I didn't do Erlang.
Of course it was, Kevlin.
Because Erlang wasn't a known thing at that time.
Yeah.
It's far enough back, and I looked at a thing called ABCL, and it was just like 1974 was like Carl Hewitt's work, 1973, 1974, all of this kind of stuff. The scheme language. Remember I said everybody needs to have an infatuation with Lisp. Some people get an infatuation with Scheme. Scheme was invented to try and figure out what on earth Carl Hewitt was talking about when he created the ACT model. And there were lots of very interesting things that came out of that. But it's one of those things of like, eventually we're going to get, so it's a slow propagation of ideas. And yeah, it's a case of like, there's some kind of hope. But I think it's going to be not because the Copenhagen telephone exchange is still running Erlang, but people are going to start ransacking. They're starting to do half-baked. I've done versions of actor models in the past. Yeah. There's the whole Akka thing, which is kind of like, it's kind of like that's. I've not really played with Akka, but when I look at Akka, has anybody used Akka? It's when I look at Akka, it's just like, oh, this is like somebody had a conversation about actors with you in the pub. You never actually saw what actor code looked like, but we're going to say this is. I mean, it's not a bad stab at it, but it's not. When you look at Erlang, it's like Erlang is just like, yeah, we're done. Really
well, and the important thing the important observation to make, I think, about Erlang is it's not Erlang. It's the runtime. So what you have with Erlang isn't just a brilliant, simple, elegant implementation of actors. It's the most observable runtime we've got. I mean, you think JVM's got good observability, and it does. It's not a patch on OTP. If you look at how Erlang programs run and what you can know at runtime about a running Erlang system, and the dials you can twiddle, and the thing is like, okay, that's observability, and he cracked that 20 years ago, 30 years ago or something.
So that's the interesting, that comes sadly
and we never then said, right, let's generalize that, let's make that how the industry does this stuff.
Yeah, that seems to be the missing bit, isn't it? That we often have these aspirations, we often have these examples, don't we? Whether it is the technical stuff, the people stuff, we say there is a beautiful example of how we can do this. And everyone goes, yeah, that's brilliant. And then the people stuff happens that all the forces work against that. So,
well, I'll give you another example. Is if you've seen much actual Clojure code in the wild, or even Lisp code in the wild, is what people do is they pick up these languages and they start programming in them. And absolutely the wrong thing to do with Clojure or with Lisp is to start programming in it, because it's not a programming language, right? It's a language you use to design a language that you're going to program in. And so when you see Clojure done well, the first thing you build is that DSL you were talking about. The first thing you build is structures that represent your domain and represent your domain model, and functions that represent operations within your domain on those constructs within your domain, and that's what you build your program out of. And we forgot that, so you just start coding.
You do realise that there's Scala programmers out there going, yeah, that's what we do.
Well, that's a great thing with Scala programming. You can do anything, right? Just a bag of language features in a sack and just shake it up. There's bits of Scala that aren't compatible with other bits of Scala. You have to choose the subset of Scala you're going to call Scala and use that.
Today's subset is...
Exactly.
What's that? Friday. Okay, so therefore it's going to be this subset.
Now, what I like with Scala is the answer is yes. So you're like, okay, so Scala, we're going to process a sequence of values. Yes. Should we use a for loop, like an iterator? Yes. What about a recursion? Yes. Should we map reduce? Yes. Right. Which of those do you prefer us to use? Is there like an idiomatic no? No, just whatever you like. So if you have nested loops, of course, one of them will be a for loop, one will be an iterator, one will be a... And you look at this stuff going,
exciting. This is, And
you can't have too many paradigms in the same 10 lines of code.
So there you go. There's your maintenance nightmare. So 20 years, we're going to be saying the same thing. But that's on that. So what are the other things? Let's take it from the user point of view. I don't know if we're going to be using phones in 20 years, but there'll be something portable. What is it that let's go to the user side of the story. What's going to be driving stuff?
So I'm wearing my contact lenses, which are giving me a heads-up display right now of my health stats and information about you, because this is a meeting and I haven't seen you for a while, and it's telling me, oh, it's your birthday. So Kevlin, so it's your birthday next week, right? That's what this will be.
So finally,
in 20 years' time, this will be like wearable compute.
Google Glass will finally actually happen. Yeah.
Google Glass will be a contact lens.
Yeah. So
and we're shrinking this stuff. So again, the hardware side is insane. It's just the software that can't keep up. And once we figure out biological powering, right, I won't need a battery in this lens. It'll be powered by my eye. Yeah. So that won't need a thing. Yeah. And so we can certainly get to that scale. Yeah. So I think the compute itself is going to be much more pervasive even than we think now.
So I'm going to flip this a little bit. It's like, does that mean I'm going to get adverts in my eyes? It's just going to be. I can't see anything because
it's a place to advertise.
Damn it! Where's that? No.
So tell me the cause of this crash. Well, what was happening was this clothes came up.
Because it was my birthday, you suddenly got this big message popping up.
It was actually a job ad. I careered off the road. Oh, sorry.
Yeah. So there's kind of that's kind of the other side, because so there's a whole thing there with in terms of power, as exactly you say, biological. We're walking around. We have these. We're
emitting watts, right? I'm sitting here right now emitting watts.
Yeah.
Right.
Yeah.
So why not just power stuff with it?
Yeah. We what was it? Human body emits something like 40 watts. I think we're
sitting under these lights. I'm emitting more than I know.
I think the brain is rated at around the 12.
I'm charging my phone right now while we speak.
And I think the rest of the body is just like it's probably we could probably drive a decent lava lamp. So
Java lamp was that?
So we're doing that, but
I can't get up right now. I'm compiling. Hang on. Right. Okay.
Yeah, I could see that one is going to be an interesting one.
I hadn't thought of the advertising angle. Oh my goodness.
Yeah, that was one of the first things that whatever the future will hold. And it's because you primed us by saying, oh yeah, Google's two big systems, big code bases, ads. So that's going to be Java, because it's not going to be anything else, is it? No. It's at that point, and it's so basically, Java.
You'll be being woken up in your sleep, or no, it'll be like the what's it called, subliminal advertising while you're asleep. You'll be dreaming about like Coca-Cola.
Yeah, you wake up in the middle of the night.
Woken up hungry. I don't know what is it. I fancy a burger. Nom nom nom.
So human health, that's going to be an interesting one. So we've got that. And
there'll be the arms race between the people who actually want to keep you alive and the people who want to sell you stuff.
Yeah. Which so basically more of now, but just in more pores of our body. Okay, so that I'm looking forward to that. No, I'm not sure. No. But then the question about power, because it was something you mentioned in the panel last night. Let's kind of take this as humans. We are in a wonderful position to power most of our own devices, in the sense that we phones do use a modest amount of electricity compared to some of the stuff that equivalent compute power we would have had in the past. Would have generally made a noise. Would have normally been that would be one of the offices. Certainly, I worked in one place where it was a case like, no, we don't have heating in the winter because simply the waste heat from all the old style monitors and the machines was enough to keep the room warm.
Well, in fact, Denmark is a brilliant pioneer of this stuff. Is the idea of like creating these holistic organizations. So you'll have the data center next to the office, and it's like a common paradigm now, or a common idiom now, where in a data center you have what they call cold racks and hot racks. So you have all the servers back to back with each other. So all of the fans pumping hot air out are going into one aisle, and then all the faces are in the next aisle, which is a cold aisle. And all the hot air goes up, it gets gathered, and it gets piped through to heat the building. And you basically, once you've got a data center, you don't have a heating bill. Yeah. But this is a deliberate design. It was pioneered here, and it's kind of just global now.
Yeah, that's
brilliant.
But we're also eating into that, and we've got, from here where I'm sitting, I can see a windmill. We've got all of this good stuff, but we've got LLMs,
right,
which are hungry.
I'm hoping. I know I'm wrong.
20 years here. What's that going to?
Yeah, I know I'm wrong. I'm hoping this whole thing's going to implode. I'm hoping that in about 2 or 3 GOTO's time, LLMs will be as popular a topic as, say, I don't know, cryptocurrency. NFT. Anyone got an NFT? No? Oh, shame. Right? It's an absolute hype cycle. The problem is that the same people who were shilling crypto are now shilling LLMs, and they're still desperately looking for a business model for it. Right? But I think the pivot, I think the thing that we're going to need to have is to start taking things like solar power seriously. Again, Denmark is a brilliant pioneer of wind farming and wind power. Solar power is free. You're seeing it a lot in rural India, for instance. Huge amounts of investment in solar, because you put it in the middle of a village. You don't need to cable anything into the village. You just set up your solar arrays, and you're powering your town. So
there's a really interesting, I think, the long trend, and actually, funnily enough, I think it starts here and in the eye, is locality, is the idea that I don't need to have centralization for power, is that it can be fully distributed, it can be where you are.
Why not have a solar panel on top of your car? Yeah. Right? It's dead space.
And we've been talking telecoms, and the interesting thing is historically telecoms has been centralized, it's been hub-based, but now in countries that are building out, they're not actually putting in landlines, and there's a whole, this does make me sound old, and I was talking about social generations earlier on, but it's the idea, so my wife and I were having a discussion, it's like, why do we have a landline into our house for our parents?
Right.
That's the only reason we have a landline into our house, because the point is that we grew up, you ring a house and you end up talking to your partner's parents. You end up with a relationship to the whole family without meaning to. And
there's a wonderful scene in a
and I'm just thinking about back girlfriend's father was an APL programmer. Back in my teens, and it's a case of I'd be ringing up and I'd get her little brother first of all, your boyfriend's on the phone, all this kind of stuff. It's just like all of that. You end up with a relationship with the whole family. But nowadays, the whole idea is like, well, you want to ring a person, you ring the person. You don't ring the building they're in, you ring the person. Then there's going to come a point where all this other old telecom stuff feels really weird and archaic. But new countries are saying, well, that's it. You build out the cellular network. Why are you running cables? That's not a thing we do anymore. So
this happened I was working with a brilliant organization in India called GEO as a 4G telco, now 5G telco and cable and all that kind of stuff. But basically this was the model. So this chap just got a couple of 100,000 4G masts, phoned his buddy, Samsung, right, I need 200,000 masts, ship them over, gridded India into 1,000 basically areas, and he says, right, well, you live in Uttar Pradesh, you know the mayor, right, so you get a bunch of masts, plant them all in, and all over the country, all these little mini geos all planting all these masts all over the place, and he's right, switch it on, bang, 4G network. It's now the largest phone network in India. It's completely insane, and because you're absolutely right, you don't need to suddenly have this massive cabling infrastructure program around the country, you just plant a bunch of masts. And the fun thing, there's loads of fun things about this organization. One of the fun things is at the point when they did this, most of the spectrum, so you sell chunks of spectrum to telecoms firms. And different parts of the spectrum have different costs, right? So the spectrum that goes furthest, that has the longest range, is the more expensive. So all that was left was the cheaper spectrum. So that meant that they had to plant the masts much closer together than they would otherwise have in order to create this network, which then meant that switching to 5G was basically a firmware update because everything was exactly in place already. So their 5G rollout has just been ridiculous. I met these folks 7 years ago, and I remember standing in Mumbai with my phone, and I've got like just a 4G or whatever phone connection. I was getting faster data in the center of Mumbai on my cell phone than I was getting a broadband at home. Right, it's just like 50 megabits sustained broadband. I'm like,
not bad.
Yeah, that's not bad. That'll do.
So that.
So what I'm saying is, there's a real case study where absolutely you don't. You can, if you rethink the problem, and then you go satellites, right? Why even have plant stuff on the ground?
So William Gibson's classic quote is, the future is already here. It's just not evenly distributed. So we've been to 2044. We have 5 minutes left. I'd like to open the floor to questions. So. Does anybody have any questions?
We've got 5 minutes left, really. We're not very good at this, are we?
I'd say that's brilliant time management. I was actually expecting us to slam straight into the end with
having taken
still
no
halfway
questions.
through a deep discussion. So, yeah.
Yeah, I have a question. So there is different programming languages that are suitable to solve different kinds of problems. But also, if you have a unit, like my unit is around 100 engineers, you don't want to have 100 different programming languages for the over 200 microservices. So what's the right amount of programming languages in the stack of a company where you can still do on-call? I mean, everybody has been there, right? It's a classic, but I just want to know your
I have opinions on this.
Yes, thanks.
So, I like the keep things as simple as possible, but no simpler, right? So, and I'm going to mention this in my talk as well. I don't think about people as Java programmers or C# programmers. I think of people as programmers who happen to be using Java right now. And again, when you look at Go, the whole design goals with Rob Pike and his team were make an easy on-ramp for people who are deeply, deeply experts in these other languages to pick up this toy language we just invented. Right? There is no mind share on this because it only just started. We're still writing it. Generally, what I'll say is have opinions. You don't start with a 200-person company. You start with a 4-person company and you grow it to 200 people. But you go in there and I describe it as there's the Google approach to this and the Amazon approach to this. The Amazon approach you just described, right? So 200 microservices. It doesn't matter, right? Every single piece of stuff, you build it, you run it. So you're on call, you're on the pager. But it has to have an API, and these are our opinions on APIs. And once you have those opinions on APIs, it kind of almost doesn't matter. You've got the hard shell and the soft center. It kind of doesn't matter what's in the center. I think I'm not a fan of that model because I think it does lead to local optimization and it limits internal mobility. It makes it harder for people to move around outside of that bubble. And I've seen that play out as well. So the flip side is something like Google where they have essentially what they call a gatekeeper matrix. So for every product and for every technology, there's like a matrix and there's an owner of that. So if you're in Gmail doing Java, there's a Gmail Java house style. It might be different from the ads Java house style because they're different products, right? But there'll be a house style. You have to code to that style. And that part of the pull request model is the style check against that. Like you can have the best solution and you didn't use the house style. Done, right? Back at you. I think the truth is somewhere in between those because most companies aren't Google or Amazon. It's just like, big tech envy. So I'd say start with a small number of opinionated languages. Be deliberate about what good looks like. So have custodianship, and have custodianship as a first-class concern. There is a group of people across the organization who own what we think good Java looks like, or what we think good JavaScript looks like. And you may have other opinions. These are ours. Yeah. So the custodianship thing is valuable. Have a deliberate process for onboarding a new language. So I've been in a few shops where they're Java shops, and I'm introducing Kotlin. And I'm introducing Kotlin because it is a strictly better language in most use cases than most versions of Java. I mean, a lot of Java's caught up now and does some nice things, but So are you going to immediately trust me to put Kotlin into your production systems? No, because I'm some external idiot who just walked into your organization. What we might start doing is maybe using Kotlin for some TDD. We'll start writing the tests in Kotlin, because you've got the little backticks thing, and you can write test names in plain, with little spaces in, and just nice little affordances, and you gradually start introducing, and then after a while, someone else says, hey, why don't we start writing some production code in this? This is quite, and then now you've created like enough groundswell. And as soon as that happens, we say, right, custodian. Now this is a language that we're going to use. It's going to be blessed, anointed, whatever. We're going to have an opinion on that, so there'll be custodianship. So you have a deliberate way of onboarding new languages. You have the smallest set of languages you can reasonably operate with, because that gives internal mobility. And at the same time, you don't have a fear of trying new things, because they may be where you want to be going.
Cool. Right.
Thank you.
In which case, that's a very comprehensive answer. I think we are at an end. So, Daniel's going to go off, do a talk now. Then you need to tackle him just as he finishes that to ask further questions. Hinder his progress to the airport, or accompany him to the airport. It's just like, there's nothing weird about that. It's not stalking.
I'm going to be walking down to Orison Station. I'll happily take some company. Yeah.
Yeah. Okay.
It's a
Well,
lovely
thank you
sunny
very
day.
much.
Thank you.